We are honored to have with us today Anju Karanji. She is a full-stack engineer with a passion for building thoughtful, user-focused web applications. She has extensive experience having worked on large-scale systems at Amazon and real-time collaboration tools in construction tech. Anju consistently prioritizes clean design, performance, and developer experience in her work. She's keen on sharing her knowledge of design patterns and helping others develop a system architect's mindset. It's an honor to have you with us, Anju. The stage is all yours. Good luck.
Thank you. Thank you so much. Thanks for attending this and thanks for being here to listen to me. I'll quickly share my screen. I hope you all can see my screen and you can hear me, right?
We do.
Awesome. Welcome everybody. My name is Anju and today I'm going to be talking about design patterns. I know you have already been attending a couple of sessions and you've learned a lot of other patterns. But today, specifically, I'm going to be talking about design patterns with respect to performance specifically. And two of the main patterns that I'm going to talk about today, one is proxy, flyweight, and flyweight pattern and proxy pattern. And these are pretty important where performance is concerned. As I go into the talk, you will see more of how it is, how it helps us and how it improves the performance and other details. Again, welcome everybody and thank you for listening to me. When you're building a UI, as we all front-end developers, we care about three things. First thing is we want it to be fast. So we want the performance to be so great. We try to bundle split it. We try to use in React we reduce re-renders by using use memo, and we use react.memo, and we try to use callback, and we're going to try everything we can, like we're going to do lazy loading and so that the dynamic import, so that we try to reduce the first contentful paint. That means we are going to always trying to make the performance so great. Sometimes we cut corners and we try to go for hacks and things like that that tend to not be great. The other thing that we always try to aim for is we always try to follow the book, the what is that, the Clean Code book by Robert Martin, and he has these principles, solid principles and dry principles. We over-engineer things sometimes. We try to follow the KISS principle, like everything has to be just right, and we try to over-engineer. And sometimes when a new developer joins the team, they're a little bit confused, and that has happened to me too, wherein you don't know what's happening. It takes a little while to get used to it. And the other thing we always care about is scalability. When we start making the application, in the beginning, it is just an MVP. But then 6 months down the line, or 1 year down the line, we have like 1 million users or 10,000 users, and sometimes we scramble around. So we got to make it scalable. So basically, we write code for a machine to make it more performant. We write code for fellow engineers. That means we use clean code architecture and we make it just right, just the right variable names, just the right structure. And then we write the code for the company, because the company needs to grow and it has to be scalable and it has to be extensible, and so that it doesn't turn into spaghetti code like 6 months down the line. So, but everything has its cons. Fast UI tends to have, we tend to have a little bit hacky. So sometimes we cut corners, we don't reuse things. We use too much of use memo. When we use a clean code architecture, sometimes it becomes so over engineered. it it can be a little hard to know where the bug really is. Debugging can be a little hard, and trying to figure out where the issue is. Sometimes understanding and too many abstractions, too many layers uh, can add a lot of complexity. And when we try to be scalable so that 6 months down the line, it should be usable for like 1,000 million, not thousand, 100,000 users, then we try to make it just right. And it does affect velocity because the app takes longer to create, and debugging and gets affected, and performance also sometimes get affected when we try to uh, think of scalability too much right at the start. So we tend to call it the triangle of doom, because we try to balance all these three needs when we are trying to build our front-end apps. So when you want to have a performance, when you want to prioritize performance, two of the patterns that are really great and that really make a impact or difference in performance are Flyweight pattern and Proxy pattern. Flyweight pattern is uh, basically it is a thing wherein we are going to create a bunch of objects, very heavy objects, which take up a lot of RAM, and that affects the time and space complexity. The two big things that we're always trying to, we use algorithm, basically to reduce time and space complexity. Flyweight patterns help with both the things, especially when we are creating a bunch of objects which are really heavy. Then flyweight pattern comes into the picture. The other pattern that is we're going to be talking about is called proxy pattern. It's a little different from a flyweight pattern. Uh, Proxy pattern is more like a stand-in. It's more like I'm not giving you the actual thing, but I'm sending you my representative. And it's not the real thing. It is like a facade, like a, not a facade pattern, like a more like a mm, it's like a stand-in, like a placeholder object before the actual thing is instead of when the actual operation is too expensive, we tend to use the proxy pattern. To uh, to not worry too much about it, we'll go deep into it right now, and then it becomes more clear after we see through the code and when I explain more. So, uh, flyweight pattern. We're going to start with flyweight pattern. It is a pattern that basically when you have a lot of shared objects, we're going to not duplicate the object so that it doesn't take up too much space. Sorry, I'm going to minimize this. Flyweight is basically used to reuse shared structure across multiple instances. It reduces duplication of data and it makes it faster. And the main concept of flyweight is an object. If there are like a million objects or 100,000 objects, um, if they share a lot of variables between them, if they share a lot of class variables, then we are going to split it into two. Basically, we call the class variables that are shared, we call them the intrinsic state, and the ones that are going to be variable, that are uncertain, that is not guaranteed to stay the same, we call them extrinsic state. So in a way, we try to minimize the object creation by using the concept of intrinsic state and extrinsic state. When I do the code, you'll see that much better. Uh, I'm going to do a code in React. Let's start with, I hope you all can see my screen. I can't see my, you can see my screen, right?
Yes.
Yes, okay. Let's start with the flyweight pattern. So right now I'm trying to create 100K books, 100,000 books with a large amount of content. Let's take an example of, say, Harry Potter book. Fifth book is, I believe, the biggest and the fattest of all the books. Right now, nothing happens. We're going to add that code here. So it's a React app. So basically, there is an app and app.tsx, and I have two buttons. Uh, one for Flyweight and one for Proxy, and nothing else. I clicked on Flyweight and it shows me no Flyweight, yes Flyweight. So this is my Flyweight component. And basically I'm trying to create 100,000 books, and each of them have a lot of content, 20 KB of content. So right now on click of the button no Flyweight, nothing is happening. I'm calling this function generate without Flyweight. It's got nothing. Mm, And then I have another button that says with Flyweight, and it does nothing so far. Let's try the regular way without Flyweight. So assuming I have a book, and it is a, sorry, I'm going to call it a class, and it has um, a title, and it is a string, and it has an author. Again, it's a string, and it has a content, and that is again string, and I have a shelf. This is a bookstore. Let's assume it's a bookstore, and I'm going to call it and we're going to each of those books have title, author, content, and shelf. And I'm going to have a constructor in here, and that is going to take title, author, content, shelf. And it is going to say this dot author equal to, sorry, this dot title equal to title, this dot author equal to author, this dot content is equal to content, this dot shelf is equal to shelf. So this is a class called book with meta, and it has got 4 things. And in a regular way, if you had to create 100,000 Harry Potter fifth book, so what you would generally do is you're going to say, I'm also going to have a array called, I don't know, bookshop, and this is going to be my shop that contains all the books. So I'm going to have a for loop that says let I equal to 0, I less than 100K, 100K, and I plus plus. What I'm going to do is for each, every iteration, every loop, I'm going to create a book with meta, and I'm going to say new book with meta, and I'm going to say title is Harry Potter fifth book. I think it's called The Order of Phoenix. And then I'm going to pass in the author J.K. Rowling, and I'm also going to pass in content. Content is like huge content, and I'm going to say, repeat 1,000 times. So we have huge content, and then shelf number. I'm going to say math dot floor math dot random, and I'm going to have the largest max shelf to be 200. So I'm creating a book with meta in each iteration. That's the usual way, right? When we create an object, and then we add it to my bookshop dot push book with meta. So before we do that, we're going to find out how much time it takes. So I'm going to say constant T0 is equal to performance start now. So that will give me the time when before I start the loop. And then I say constant T1 and I do performance start now. That gives me the time after. So my duration is T1 minus T0, and I'm going to say to fixed to the decimal point to, and I'm going to say this is the usual way, right? Like we always say we always create an object and we push it to the wherever the data structure that keeps all the objects. So we're going to say duration to create. So I'm going to send in bookshop dot so what I'm doing is for 100K books, which is the usual way of doing, I'm going to create an object, book with meta, and I'm going to send in title, author, and the content, and some shelf number, which is randomly chosen between, which is going to be less than 200, and I'll push it to bookshop, and I'm going to calculate the performance before I do the creation, and then calculate get the time before I start the operation and after I stop it, and find the duration. So if I do it with no flyweight, I can see I took 33.30 milliseconds to create 100,000 objects. But if I do it with flyweight, what I'm going to do is I'm going to use the same book with meta. I'm going to copy it there because it's easier to do it if you understand when it is right in front of you. So as you can see, these three things are intrinsic variables because they don't change: title, author, and content. Because a Harry Potter fifth book is always going to have the same title, same author, and the same content. The only thing is where in the bookshop, which shelf is it located is what is going to change. So these things are my intrinsic variables, and this is my extrinsic variables. So what I'm going to do is, instead of, since I know these intrinsic variables are going to be duplicated everywhere, I'm going to put them in a separate class. I'm going to call it class book. And I'm going to use these three. And I'm going to use the constructor. But this class is going to have only the intrinsic variables. And now I'm going to use a map to keep track of it. I'm going to call it book map. It is going to have a string, which is the title, is the key, and the actual book is the value. Now, instead of doing this way of just directly creating the object every time, what I'm going to do is I'm going to create something called as create book. And this create book is going to, the loop stays the same. I'm going to copy the loop because we do need the loop, but I'll add that part later. But we and we also need to use the live bookshop to. So what I'm going to do is when I create the book, I'm going to check if it is going to take these four things. Now we're going to create a book as it is. So when we create the first we're going to check if the book map has that value already. If book map dot has the title that we are looking for, then we are going to return the book map dot get of title. Because if that book map already has it, then we are not going to create another new object. Only if it does not have, then we are going to say constant new book is equal to because the intrinsic variables are in the book object. So we are going to create a book class. So we are going to create a new object that has only the intrinsic variables, which can be reused further. And I'm going to use the same things. And I'm also going to enter it into bookmap dot set of title, comma, new book. And now I'm going to return the new book. So instead of creating it directly, instead of creating an entire book meta, I'm going to create an object called using the method create book. I hope it's clear. It's not too confusing. Now here I'm going to see if I'm going to, instead of creating a new object of book with meta, I'm going to say book. I'm going to say create book of title is same title that I used here. Harry Potter book, we did it all the with those things. So it is going to go to create book, and if an entry already exists in the book map, then I'm going to send it already. Otherwise, I'm going to create a new one and make an entry in the book map and give back the book object. Now that I have the book object, I'm going to create my book meta object. So I'm going to call it book with meta is equal to new book with meta. And here I'm going to send in, I spread my book and I pass in the external content that external extrinsic variable that I need to add to it, which is nothing but the shelf number. Give me 1 second. So I'm going to create book with meta with my new with my constructor book with meta, and I'm going to pass in the this book's title that I got, and this author I got from the book object, and this content I got from the book object, and the other the extrinsic value, which is nothing but the shelf. And now I'm going to push it to my bookshop. Bookshop.push. I'm going to push it to bookshop.push. And then I'm going to calculate the performance, sorry, the time using performance.now after pushing it into my bookshop. And then I calculate the duration. And I'm going to copy and paste the same thing here to see the difference. Here I'm going to so I'm going to show the difference in the when we do it like the regular way with no flyweight. Takes about 40 milliseconds and it creates 100,000 objects. But when we use flyweight, it takes 14 milliseconds to create one object. So what is happening is we are going to reuse the same object because we know that this Harry Potter object is going to be consistent over 100K of those books. So we are going to reuse that intrinsic variables into our into each of the same object will be reused multiple places. So we save up a lot of time that way. Um, Let me go back to my that is flyweight pattern. Uh, Pros and cons. It really reduces memory usage. To be completely fair, with these modern day computers with MacBooks with M1, M2, and all that, with high RAM, we don't have this problem as much now as it used to be before, but it can still help in reducing the amount of memory we take up. So it's still a great way if you have really heavy objects with a lot of data and a lot of content. It is still a very useful data design pattern to make use of in our coding. Cons would be because that object is shared across 100,000 or millions of objects, and it is if you make a change in one object, it is going to be reflected in it's going to be reflected everywhere else. In our case, it is not a problem because book content, if it changes, it's good for it to reflect in every other object. But you have to be mindful of where you're using. In this scenario, it works perfectly because the book content has to be same. The first line, Harry Potter this does something, has to be reflected in every other book. The changes have to be consistent, but you just need to be mindful um, of where you're using it, and if it is the right pattern for you at that time and space, the time and moment in coding. Now let's move on to the next pattern, which is called the proxy pattern. Proxy pattern is a little different. It's a little unlike Flyweight pattern. Proxy pattern is a way wherein you have a stand-in, a placeholder. You have somebody representing you. It's a more popular pattern in backend, but it can be a useful pattern even in the front end. So basically, if there is a really expensive operation, it can be a network call that takes up a lot of time and space, or it can be a CPU heavy operation, or something that is an expensive operation, but you want to uh, restrict access to it, or you want to do some extra behavior basically, or you want to defer doing it, or you want to do the thing much later or something. Basically, you have the actual thing that does the work, but you don't want to access it because it is super expensive or something. You want to add extra behavior to it, then you use a proxy. When I go into the code, it will become more clearer. Basically, a proxy is like a placeholder object that can be used to represent the actual thing, the actual object. Also, it can add extra behavior to it. If your actual CPU computation does something, you want extra behavior like caching, or you want to add logging to it, or you want to restrict access to it like authentication or authorization, then a proxy pattern is a great way to do that. Um, it's great with optimization, and uh, when when I show the code, it will become much more clearer. Uh, I believe my code is already running. So right now, nothing works. Yes, proxy, no proxy. So this is my uh, proxy demo. It's got two buttons. Basically, I'm going to run a super expensive math operation, and on the click of a button, I'm going to do one with no proxy, and I'm going to do the other with the proxy. So right now there is nothing going on. Test proxy. I'm going to create a super expensive operation. I'm going to call it super expensive operation. And I'm going to say uh, it's going to take a variable called input, and I'm going to make it a number. What it does is there is some I'm going to loop through this, and I'm going to loop through this 1,000,000 times. And each iteration, I'm going to add a value, some math dot square root of the input number that I'm getting. So this is a heavy math operation. And then I'm going to, and then to fixed, we're going to get that. And then I'm going to return this value dot to fixed. So this is a super expensive operation. If I use it without any proxy, so what I'm going to do is when I'm going to calculate the time that takes. And I'm going to call this super expensive operation. And I'm going to pass in 50. And then I'm going to get the time that it ended, at which it ended. After I make the super expensive operation, which is like 1,000,000 records, it is going to be an expensive operation. So I'm going to return the result. The time it took, T1 minus T0 dot to fix stuff. So I'm going to say it took that much millisecond to generate the result that we're going to get. This is the result we're going to get. So this is my super expensive operation, which is the main thing. And this is without any proxy. Without any proxy, we are going to call that an super expensive operation, and we're going to return the result. This is no proxy. It took 3 milliseconds to 3.10 milliseconds to generate this much data. But if you're going to do it without proxy, that it takes that much. My bad. If you're doing it with proxy, then what you're going to do is you're not going to make the super expensive operation call immediately, but instead we are going to create the proxy object. And JavaScript automatically on its own gives us a way to create a proxy object. I'm going to use the same code. And instead of super expensive operation here, I'm going to call the proxy. And we're going to use that proxy. We're going to define that here. And oh my bad. It's a way of doing it. It JavaScript provides us directly, and it takes in two input arguments. One is the actual super expensive operation that you're trying to proxy, that you're trying to emulate, which is this. and then it takes in and methods as a second parameter, which we are going to define now. And inside that proxy object, we call it the trap method. It's only specific to when you're creating a proxy object, and it can be get, set, apply, and a couple others. So I'm going to use apply, and it's going to take target. I'm going to take this args. I'm going to take args, and we're going to get the value that we're sending here, this 50, this value, we're going to get it and into say current arg is equal to arg of 0. And the current arg will have the 50 now. And we're going to also use another map here. We're going to call it cache, because this is a very popular way of proxying caching. An expensive operation every time you do it, it is going to be super expensive. When what we're going to do is we're going to add a layer of caching in our proxy. I'm going to call it cache map, then do new map. It's going to take a number and return a number. I mean, key is number and value is also number. So here, when I get this value 50, I'm going to check in my cache basically if I've already done that super expensive computation on that particular input. If I've already done it, I'm going to return it as is. If cache map dot has that current arg, then I'm going to send cache map dot get of that current arg. I'm going to return that cache map dot get of current arg, that particular input that I'm getting. If it is not there, then I'll have to do the computation again. So that means I have to call the actual super expensive operation. If it already exists and I send it, if I don't have it, then I'm going to call the actual super expensive operation. I'm going to say, I'm going to do target dot call. I'm always a little bit unclear about the syntax. Yes. Target dot call of this args, comma, basically our I have the right syntax. So the result is going to use the if the cache map doesn't have the value already, I'm going to make a call to the actual expensive operation, and I'm going to return result. But before I do that, I have to enter it into my cache map dot set current arg with my result. So here I'm going to send super expensive operation proxy instead of my actual super expensive operation, and I'm going to pass in 50, which is going to go here and use the Java inbuilt, which Java JS already provides, that new proxy, and create a new proxy object, and then which takes in two parameters, super expensive operation, and then our trap method that is going to trap the And then here I'm going to check the cache. I'm going to check the cache and see if it already has that value stored somewhere. I'm going to send it. This is the extra behavior a proxy is going to add on top of the actual super expensive operation. If it doesn't have it, then I'm going to make make the actual call to the function and enter it into my map and return back the result. And here I calculate the time it is going to take and return the result. So we're going to test it out. This is the proxy pattern. This took 3 milliseconds to generate, I don't know how much it is. Yeah, 7,071,000 records approximately. But with proxy, it is going to take 0 milliseconds to generate the same number, same value, because it is going to our proxy object is going to check if it is already in cache. If it is in cache, it is not going to compute the expensive operation again. So we save 3 milliseconds this way. Now, so key takeaways. Flyweight pattern, it minimizes memory usage and sharing data across objects, ideal for applications with many similar objects. Proxy pattern controls access to objects through a surrogate or a placeholder. It is great for lazy initialization, lazy loading, and control access to certain this expensive network call or something. Like if only a manager is supposed to do it but not a regular employee, we are going to restrict access to it with the help of this proxy. Or sometimes you want a library, really heavy library, and you don't want to load it right away, so you're going to use a proxy in all the places, and only when it is required to do it, then you're going to access that library or import that library. So that is the big main difference between flyweight pattern and proxy pattern. Thank you for listening. Stay in touch. That's my LinkedIn, and that's my if you want to look at the code for proxy and flyweight patterns, it is at the repo. That's a GitHub repo.
Thank you so much for the great example, Anju. It was really well structured, and I think we all loved the example with the flyweight and without flyweight, and with proxy and without proxy. That was really impressive to see the difference with using the pattern and without using the pattern.